Okay, so lesson 9.1, chapter 9 is quadratics. So quadratics, we're talking we already saw the U-shapes, the parabolas. So when we talk about this, we're talking about the x squareds, which we did some with last chapter because we started the factoring and foiling. And so we're going to be looking at that. First couple lessons are graphing them. So that's what we're going to work on here. So quadratic function, some information, standard form, y equals ax squared plus bx plus c is our standard form there. Today, we're honestly just looking at those. If I recall, we're looking at the ones that they don't have the bx. They just have the ax squared and then possibly the plus c. So it makes it a little bit easier. The parent function, so like what they are all part of, the family they're all part of, is the x squared. So they're all going to be parabolas, maybe right side up, maybe upside down, maybe fat, maybe skinny, just depends. So the graph is the U-shaped curve called the parabola. Axis of symmetry. Axis of symmetry is a line that divides the parabola into two matching halves. So we usually draw it as like a dotted line, but divides into two matching halves, so where you can fold it on top of each other. And I'll show you on this picture here in a moment when I scoot it down. The vertex. We talk about the vertex, we're talking about that either top of the U shape or bottom of the U shape that's down off the screen. It's either the highest point or the lowest point, and it's also on the axis of symmetry. I'm going to scroll this page up a little bit. And then look at this. Okay, so based on this right here. So first of all, as we look at this parabola over here, this parabola, and I'm going to put my arrows on just because it's bugging me, but a parabola, it's that U shape that keeps going up and up and up. If A is positive, so when we talk about if A is positive, if the x squared term is a positive term, then that parabola is going to open upwards like this. Okay, the vertex will be a minimum. So this is my vertex here, and in this case it's a minimum because it's at the bottom of the screen or at the bottom of the parabola. Okay, so minimum at the bottom of the parabola, and then we mentioned up above it's found on the axis of symmetry. Yeah, so axis of symmetry, we usually just draw it in as a dotted line. And it is that dotted line that cuts my parabola into two equal halves. Okay? Does that vocabulary sound a little familiar somewhere in there? Maybe, maybe not.
No, but I'll learn it.
You'll learn it. Okay, sounds good. Okay, so the only difference over here on this other one is this parabola is upside down. And this parabola is upside down because it's a negative x squared. So when it's positive x squared, the parabola opens up. When it's negative x squared, it is upside down. Okay, so difference is my vertex is now at the top. So there's my vertex, and that is a maximum point. And then we still would have the
Axis of symmetry.
Yep, axis of symmetry. Okay, so anytime we talk parabolas, those are good vocabulary words to have. Vertex and axis of symmetry. Now, I'll be honest, I forgot this was in here. I took these notes from before we had Math Excel, and we did more book. I'm curious real quick. I don't even know because I haven't, you know what? This isn't even from this book. This is from the previous book.
I used that book in 8th grade.
And 9th grade.
No, we didn't use it in 9th grade.
Oh,
We
because
used
you had Math Excel.
Those notes in Math Excel.
Yeah. I was gonna look. Yeah, see, this page number's not exactly right anyways. I just forgot. I totally spaced on deleting it out of the notes. So. Okay, so. You have some of this to do in homework. when you look at the Math Excel lesson. I will just project my book here onto the screen. The only problem is it's not going to be in the recording now, but
Oh, I do remember this from last year. A little bit.
coming back to you a little bit.
Yeah, I remember having the graph of it.
Yeah. My examples there that I'm referring to in the book, you're going to see problems like this in homework, where they're going to give you a parabola, and they're going to say, okay, what is the vertex?
Yeah, 2.
So the vertex is where? It's up here at the top of the graph, right?
Yes. Yeah.
And so then we go, to get to that point, we go left to right 0 and up 3, it looks like.
Yeah.
And so my vertex would be 0, 3, and it is a
Positive. Well, no, it's -1.
it's a negative parabola, so it's upside down.
Yeah.
Where is that vertex at? Is it at the top or the bottom?
Top.
At the top, so that makes it a
Max.
maximum. Okay, so just realizing it's a maximum if it's at the top, it's a minimum if it's at the bottom. And then just being able to find what that ordered pair is. Okay? So, I'm not going to spend a bunch of time on that because we will work on that some when we graph them. But, okay. The next part talks about comparing widths of parabolas here in the notes. And the a value. So when we talk about ax squared, try that again. Sheesh. Okay. So y equals ax squared. When we talk about the a value determines the width. Basically, the bigger a is as a number, then nope. It's going to get taller, which makes it skinnier.
Oh, yeah.
That a value really determines, it's more of a stretch versus a shrink. Now, those are my Algebra 2 words, okay? Not the Algebra 1 words. But it determines the width in that an a value, the bigger the a gets, the taller it makes it. And so if something gets taller, in this sense, it's going to be stretched upward, it's going to get skinnier. Whereas if that a value, so let's see, the smaller the absolute, okay, I guess I switched them. The larger the absolute value of a, the narrower the parabola, so the skinnier. Whereas the smaller the absolute value, so if we're talking basically like numbers less than 1, like fractions and decimals, that's going to make the parabola shorter. And when it gets shorter, it gets squished down, and so it's getting wider. Does that visual make sense there?
Yeah.
Okay. And I think probably these problem 3 examples. Let's see if they talk about it. Yeah. So here's a visual for you. If we look at these.
Yeah.
Negative 4x squared. It's upside down because it is negative. And 4 is a big number. That's a number bigger than 1. And so that is stretching it. It's making it skinnier. And I should say in comparison to x squared over here, which this is your regular graph. So this one's skinnier because it's a 4. This one, middle one, has a 1/4. And that makes it wider. Okay? What word did you use? I know. I say that, so I try to avoid using that. But I get it. And then before we go graph one other reminder, domain. I bet domain you guys talk about in algebra, first semester algebra 1, don't you?
Not yet.
I bet you do. But domain are your x values. Range are your y values. And you would have talked about it in middle school math. It's not brand new. At least I don't think it is. So, okay, so that's domain and range. Okay, we may only do one here. And that way we can come back tomorrow and practice. Well, we may do 2 based on what the first one is, but we'll see. We'll do 1 or 2 at most and then call it quits for the day. So, as we go to graph, y equals x squared. You know the basic shape, right?
Yeah.
However, we need to know specific points.
Yeah.
So what is a good way to find specific points if you don't know them?
I'm not sure, but it starts in the very middle. That's the vertex.
I agree. Okay, we know it's going to start in the middle, and that's going to be our vertex. Okay. Now, my suggestion is going to be like an XY chart, and we can do this one of 2 ways. Because it is a parabola, we can use the idea and just use 0, 1, 2. And because it's symmetric, if we use 0, 1, 2 and get the right half of the parabola, we can flip it, reflect it to get the left half. Okay? So if we put 0 in here, you put 0 in for x, what is 0 squared?
1.
You're thinking too hard. 0 times 0?
0.
0. Okay? Now what about what happens if we put 1 in instead and do 1 squared? 1 times 1 is 1. What about if we put 2 in?
2 squared is 4.
2 squared is 4. 2 times 2 is 4. So, and with these that we're doing, our axis of symmetry right now is going to be x equals 0. Because we haven't talked about moving them left or right or anything. So if I put my axis of symmetry in here at x equals 0, so we have a point at 0, 0. 1, 1 means I'm going to go over 1 up 1. 2, 4 means I'm going to go over 2 up 4. Now that's half of my parabola. How do I get the other half?
Do the exact same thing on the other side.
Yeah, reflect it. 1, 1 is 1 to the right, so put an equivalent point 1 to the left. 2, 4 is right 2 up 4. Instead of going right 2, put an equivalent point that is left 2. Now, keep in mind, and I'm not the best at drawing these on the BenQ, I've realized, it's a U, not a V.
Yeah.
So try not to make it pointy at the bottom. I know it happens with me sometimes. Try and make it curvy. As long as I can, like mine's not the best right here. Mine's probably a little closer to pointy than it should be, but I can handle this. Okay. I don't want you to make it look definitely like, oh yeah, that's a V. Like, no, there's curve there. Now, before we move on from this one, it does ask us to talk about domain and range. Now, we talked about domain and range. Domain were which kind of values? X. So x values, keep in mind, which axis is my x-axis? The left one. Left one doesn't make sense to me. How about the horizontal, right?
Yeah.
So that the horizontal is my x-axis. So that means my x values are the values that run left and right. So how far, keeping in mind that this parabola doesn't end here, right? This parabola keeps going on. How far left is this parabola going to go?
Well, it's at 4.
It's at 4 right now. Well, that's the y value.
Oh, well, okay.
The x value,
It's at 2.
it's at 2 and negative 2. Is it going to stop there?
No,
No, what's it going to keep doing?
it's going to keep going.
As it goes up, it's going to keep getting wider and wider and wider, right?
Yes.
Technically, does it ever stop? No. So our domain, our x values, are what we call all real numbers. Okay. It's all real numbers because that parabola keeps getting wider and wider and wider. Any x value we put in there would work. Okay? So, in all parabolas, here's the good news. All parabolas are going to have a domain that's all real numbers because they're always going to be getting wider and wider and wider, even if they're upside down. Now, range. So this is about y values.
Okay, so it's 4 right now, but it just is going to keep going more and more.
Okay, so the high point we have is 4, but my arrows go past that and it keeps going up and up and up, right?
Yeah.
So it's going to keep going up and up and up, right? Forever and ever.
Mm-hmm.
Where did my y value start, though?
0,
0,
0.
0, yes? So my y value started at 0. Did we have any numbers below 0?
No.
And will we have any numbers below 0?
No.
No. So my range are going to be the y values that are above 0. And so in order to say that, I can use an inequality symbol and say, I'm going to use y, because we're talking about y values, greater than or equal to 0. So your range is always going to be y less than or greater than some number.
Okay.
Domain's always going to be all real numbers. And this time it was greater than because my parabola was going up. If we were going down, it would be less than. Yeah, it'd be less than or equal to whatever that top point is.
Yeah.
Okay? So maybe this sounds a little familiar.
Yeah, I get it.
Okay. Now, where are we at? I think we're going to stop there.
Okay.
Just because I don't want to get caught in the middle of this next problem. Okay? So we've kind of looked at some of the basics. We haven't gone into, okay, what if there's a number in front? But hopefully Jacob will be back tomorrow and we can clue him in on a little bit of some of this other stuff and then move forward. So
I'll be back tomorrow.
if not, I don't know. We'll see. And you can start looking at the homework. Some of it you could probably do because some of it I think is, if I recall, like what's the vertex? Is it a min or a max? Some of the graphing you're not going to want to do, you know.
Yeah.
So, and the homework is listed as due tomorrow, but I'll change that.